London dispersion forces are a temporary intermolecular force that occurs between molecules as a result of the attraction between the positive and negative charges that are caused by the uneven distribution of electrons in the molecule. Here we have an example of a London dispersion force in between two molecules. The electrons, represented by the black dots, are in constant motion in the molecule. Eventually, this will result in one side of the molecule with a large amount of electrons, creating a negative charge, or a side where there are a smaller amount of electrons, creating a positive charge. The positive and negative charges of these two adjacent molecules are attracted to one another and create a temporary intermolecular force. However, this is only temporary because the electrons are in constant motion and will move to a different part of the molecule, creating a different charge and breaking the IMF. This is because they are nonpolar molecules and therefore do not have a set charge. The larger the molecule, the stronger the London dispersion force. London dispersion forces occur between nonpolar molecules. The London dispersion force is the weakest intermolecular force. To find if a IMF is actually a London dispersion force, subtract the electronegativity of the substances bonded. If the result is less than 0.5, the IMF is a London dispersion force because it means that the molecules are nonpolar, which is the only type of molecule that the London dispersion forces can occur between. Identify which of the following substances will have a London dispersion force as their intermolecular force. The molecules methane and oxygen have London dispersion forces. H2O is a hydrogen bond. Subtracting 2.5, the electronegativity of carbon, from 2.1, the electronegativity of hydrogen, we get 0.04. Since this electronegativity is less than 0.5, it means it is a nonpolar molecule, and therefore can only be a London dispersion force. Oxygen has the electronegativity of 3.5. When you subtract 3.5 from 3.5, it gives you 0. Since this is less than 0.5, this tells me that this molecule is nonpolar, meaning that it can only form a London dispersion force. The electronegativity of H2O is 1.4. This is larger than 0.5 and cannot be nonpolar, therefore meaning it cannot be an LDF. True or false? London dispersion forces occur between polar molecules, and London dispersion forces are the strongest intermolecular force. Both are false. London dispersion forces occur between nonpolar molecules and are the weakest intermolecular force. Which of the substances below will have a stronger London dispersion force? Decane will have a stronger LDF as it is a larger molecule.